drive home the point that there is a faster way to do these sometimes, depending on the problem. And the thing, it's called synthetic division. That's what we're going to do today. So most of you probably use long division to do this. I use synthetic division. You can see the amount of work that it takes is way, way less. The amount of time that it takes is way, way less. I think probably every single one of you, if you were given the choice between doing 10 problems using long division or 10 problems doing synthetic division, you'd probably choose synthetic division in a heartbeat. Yes, am I wrong?
You're right.
All right. So we're gonna learn how to do this today. Question.
If there's sometimes you can't use it.
There is sometimes you can't use it, and that's really kind of the most important thing that's on this slide right here. The only thing I really want you to focus on for right now. Synthetic division is awesome and it's fast and it's really easy, but you can only use it when you're dividing by a first degree polynomial. Meaning you can only use it if you're dividing by something that's like x plus 5 or 2x minus 1 or something like that. If it's got an x squared in the bottom or any higher exponent than a square, then you can't use synthetic division. So please don't get salty with me about how you had to do 10 problems the long way last night when I could have showed you the shortcut yesterday. And why didn't you show me the shortcut yesterday? Well, none of the problems you did last night would have qualified for synthetic division. Okay, if you can't use synthetic division, your only other choice is long division that I'm aware of. I'm sure there's some other little weird shortcuts out there for long division as well. So yeah, let me show you synthetic division. We're going to talk about these last two bullet points tomorrow. I'll show you how you can use this to evaluate a polynomial function. So here's that function stuff again. And I'll show you how you can use it to check whether something is a factor. But for today, let's just make sure that we're all good with the mechanics of synthetic division. And so to that end, let's look at the same problem that we just did a second ago. So if you haven't written the original problem down in your notes, go ahead and copy the original problem down. Because the first thing that we're going to talk about is how to translate from the problem. Oops, sorry. We're going to show how to translate from the original problem into our synthetic division format. Then I'm going to show you how to do the synthetic division. Then I'll show you how to translate your answer back into your final answer. How many of you guys are pretty certain you understand how to do this already? If you want to, as always, if you want to just go ahead and start on the homework assignment, you're more than welcome. Now, there's one thing I'm not sure that you would have done last year, and that's, and don't write this down, it's just a temporary change. If you had a coefficient out in front, do you know how to deal with that? You have to do something extra at the end of the problem. If you're not sure, then when we get to the advanced example, you might want to pay attention to that. It's a little bit different if you got a coefficient out in front. It's not doesn't make it any harder, it just adds one tiny little step you got to do. All right, so get comfortable. If you guys want to turn your desks around so you don't have to have a sore neck when you get to lunch, you're welcome to. We can always rearrange the furniture, guys. All right, let's do this. Synthetic division. We're going to start with our denominator when we're dividing by. We're going to start by finding the roots of the denominator. You guys remember how to find the root of something? How do you find the root of something? No? How do you find the root of something?
You do the opposite.
Set it equals 0 and solve. The root of x plus 5 is negative 5. The root is negative 5. And that negative 5 is going to go in a little box in the upper left-hand corner. We're going to be using that a bunch as we do the problem. Then we'll deal with the thing that we're dividing, and we're specifically focusing just in on the numbers, the coefficients and the constants, also their signs. And I'm going to list those numbers in order going off to the right from this box here. So 6, positive 37, positive 30, and negative 25. The signs are important, so make sure you don't lose the negative on that 25. Yes?
Now, if there was an exponent that was like skipped, we put a 0 placeholder, right?
Correct. So getting a little bit ahead, but yes, if we skipped over one of our exponents, if we were missing a term, we have to put the 0 in this time. Yesterday I said it was a strong recommendation. For synthetic division, if you don't put that 0 in, it's going to be wrong. And we'll deal with that. The next example actually deals with that. Other questions before we move on? All right, so that's it. We're gonna end up with 3 rows of numbers here. So leave a little blank row underneath, and then a bar, and then there'll be 1 row of numbers underneath that bar, and there's a little box underneath the last term in that bar. So that's it. We've translated the problem into synthetic division form. Now we just have to go through the steps. All right, so remember yesterday there were 3 steps. Divide, multiply, subtract, divide, multiply. We just kept doing them over and over again. This time around, only 2 steps.
Woo!
So the 2 steps are add and multiply. And when we multiply, we're always going to multiply by the root. Remember what our root was for this problem? -5. All right, so we're going to add. When we add, we're always going to be adding going down. And when we multiply, the result of our multiply is going to travel up and to the right. All right, so that's it. We just add, multiply, add, multiply, add, multiply until we fill out those 2 bottom rows. So let's begin. We're going to begin by adding. We're going to add 6 with the thing underneath it. There's nothing underneath it, so our answer is just 6. The result of addition always ends up on the bottom row. So I did 6 plus nothing and got 6. Now I'm going to take that 6 that I just got and I'm going to multiply it. What am I multiplying it by? Times -5. Always by the root. Our root was -5. So I'm going to multiply 6 times -5 to get -30. -30 is going to sit right in that spot up there. We've gone 1 time through, and we just rinse and repeat until we're done. So adding going down, 37 plus -30 is 7. And then we will multiply by the roots. So times -5. 7 times -5 is -35. And then add, and then multiply, and add, and multiply, and just keep going until you're done. You don't have any space left. So, what do we got here? -5. Gets multiplied by the root, which also happens to be -5, giving us positive 25. 1 more addition here, and we'll be finished. And those actually cancel each other out. We get a 0 down here. That's the process. Add, multiply, add, multiply, add, multiply. So you get done. Any questions about the process?
You just only do it 1 time?
Just once. Isn't this amazing?
So the answer is...
No. We still have to translate it to the answer. So we'll talk about how to translate in a second. But first, does anybody have any questions about the process? You too. All right, let's translate this into our final answer here. So the thing in the box is not the answer, it's just a portion of the answer. That's the remainder. Whatever you end up with in your box is going to be your remainder. Now in this case, we don't have a remainder. And then when we translate, we're going to work our way to the left from there. The first thing left of there is going to be our constant term. And then we're going to see our x term. And then the next thing is going to be our x squared term. If we had another one to the left, it'd be x cubed, and then x to the 4th, and x to the 5th. But we only went up to x squared. So our final answer will be 6x squared plus 7x minus 5. We had a remainder of 0. What were we dividing by originally? We were dividing by x plus 5. Now, typically I wouldn't write the remainder portion in there. I would just have the polynomial. If you have a remainder of 0, there's really no need to include that fraction. And that's it. So you got to be comfortable translating from the original problem into synthetic division. Doing the synthetic division is pretty easy. Then you got to translate it back out. Questions? All right, I want to focus just on the process part of it, the synthetic division process. So I've kind of blocked out the original problem here, and I've set up the synthetic division for you. Leave a couple lines. We'll come back and write the original problem in a minute. But just go ahead and copy our synthetic division here if you would, and go through that process. Add, multiply, add, multiply, add, multiply. Let's just make sure you got that part of it down. When you get that done, check with a neighbor, and if you're feeling pretty confident together, then see if you can translate that into the final answer. So I'm going to show you the original question in just a moment, but I just want you to focus right now just on doing the synthetic division. Make sure you're comfortable with that process. And please let me know if you need a reminder to do first. Practice this without a calculator, because you have to use these calculators on your quizzes. Once you get done, go ahead and check your numbers and make sure that your numbers are correct. And if they are, then go ahead and see if you can translate that into what your final answer would be for this, or at least as much as you can. We don't have the original problem, so we don't know what we were dividing by originally. Although you may be able to figure that out. But let me know if you're not getting those numbers. Please let me know. Yes. That is correct. Can you see if you can figure out what the original problem is? That would be my next. Yeah, that's it. That's it. So if you're able to translate this and you're feeling comfortable about that, then my next challenge to you is, what's underneath this gray box here? What would the original problem be? Can you look at the synthetic division and go backwards and see and tell me what the original problem would have been?
X plus 3. Shh, don't take it away. Spoiler.
So once we translate this, what are we going to have? Constant x squared, x to the third. So 2x to the third plus 3x to the first minus 11 with a remainder of 25. And that should go over whatever we're dividing by, which we don't know until we predict what the original problem was. What are we dividing by in our original problem?
X plus 3.
X plus 3, good. Right? How are we going to get a root of -3? It must be an x plus 3 on the bottom. If you were able to figure out that that was the original problem, that's amazing. Good for you. If not, no big deal. That's kind of a little bit beyond what I'm expecting for today. Now let me ask you a question. How many of you that wrote down the original problem, how many of you wrote a 0x squared in there? Anybody do that? Yeah, and that's technically correct. It's unnecessary to write a 0x squared, but technically that is correct. But there is something really, really important that I need to point out here, and this is going to be the thing that's going to cause the most mistakes on this topic. So please pay attention. If I were working this original problem, and I noticed that it was missing an x squared term, it is absolutely necessary for me to include this 0 in here to represent that space. Okay? Yesterday I told you it was a good idea. With long division, I said it was a strong recommendation you put those zeros in there because that keeps everything spaced out, lined up even, right? Yesterday it was a strong recommendation. Today it is an absolute necessity. If you miss the 0, you're going to get the wrong answer every single time. Okay? You must put those zeros in or you're going to get the wrong answer. All right. See if you can do one start to finish on your own. Get my attention or somebody sitting near you's attention if you need a hint to get you started. Is that it?
You're really moving that one.
You're lucky you looked at it. You're very trustworthy.
I apologize.
No problem. I'm glad you found it. Oh, do you guys notice that we skipped a term here?
Yeah.
Did you put that 0 in? If you forgot that 0, stop.
Everybody be dope.
If you forgot the 0, stop. Go back, put that 0 in because it's not going to come out right without the 0 in there. Are you volunteering to write your answer up on the board? Okay. Hey, would anybody like to volunteer to write your solution and answer up on the board?
I would not trust Caleb because I just had to tell him to add the 0 because he almost.
I need you to finish it up first.
So for the 3x4,
Mm-hmm.
so you just drop it straight down the 3.
The 3 drops straight down.
Because there's nothing underneath it.
Correct. So there's always, when you set this up, when you set up your synthetic division, there's never going to be anything underneath that first term. That first term's always going to just drop straight down.
Okay.
Well, you're adding it with nothing. You're volunteering? We got a mistake there someplace. See if you can find it. Volunteering? Let me check my solution here. It's close. All right, I got it, Mr. Height.
For the remainder, you have
Sorry guys, I already have volunteer. Check it with the people around here, make sure you're getting it correct. We do have one more thing that we need to do here as soon as Caleb gets done writing the solution up on the board. And that's going to be the advanced level problems. How do you deal with when the thing you're dividing by has a coefficient? Keep working through this if you haven't finished it, and then check your answers with Caleb's here in a second.
We have more.
One more examples and slide it up. So far we've dealt with the basic version of synthetic division. For basic level problems, you're never going to see a coefficient out in front of the divisor. Guys, please. When we get to the advanced level ones, you are going to have a coefficient out in front of the x on the bottom. I think you guys do something. Do you want me to scroll it for you?
Yeah.
Can I get the thumb meter right now and see where you guys are at on this? Alright, that's good, that's good. So one tiny little detail that we got to worry about in the advanced problem is basically going to be the exact same process we've been doing for these ones, except there's one thing we got to worry about at the end. Nicely done. Thank you, thank you. Alright. Advanced level problems, you're going to see a coefficient appear in front of your x on the bottom. So we're going to divide by something that's still going to be a first degree polynomial, but it's going to have a coefficient. Which means that more often than not, the root that you're going to get is going to end up being a fraction. We are going to have to deal with some fractions, but the problems that you're going to be doing in this section are pretty straightforward. The fractions aren't too nasty. Keep doing that. That second bullet point there, though, that's the key thing. Very easy to forget to do this. It's not that difficult to pull off, but it's very easy to forget to do it. If you got a coefficient in your divisor, then you're going to have to divide by that coefficient at the end. After you've done all your synthetic division, your quotient, not your remainder, but just the quotient on that bottom line, is all going to get divided by whatever your coefficient was. In this case, we're going to, at the very end of the problem, we're going to divide everything on our last line except the remainder by 5. And then we'll write down our final answer when we finish. So it literally takes you an extra 2 seconds. Maybe 8 seconds. It's not difficult. The difficulty, for me anyways, is just remembering to do it. So if we were going to do this using synthetic division, we'd start off the same way as before. We'd find our root. Can you guys do this in your head? Set 5x minus 1 equals 0 and solve. What are you going to get? 1/5. Is anybody nervous that we're going to be multiplying by 1/5 over and over and over again? So you know how to multiply by 1/5?
Times it by 1 and divide by 5.
Wonderful, thank you. Multiply by 1 and divide by 5. You guys don't know how to divide by 5. So it's going to be great. Go ahead and write your coefficients down. I always scan to see if I'm missing any terms before I start writing my coefficients down, because I'll forget to put zeros in if I don't look for them. And I don't see any place where I'm going to need any zeros in this one. And then the steps are exactly the same. Add, multiply, add, multiply, add, multiply. It's just we're multiplying by 1/5 this time.
Wait, so you're dividing by 5?
When I multiply by 1/5, I multiply by the thing on the top and I divide by the thing on the bottom.
Okay.
So in my head I would do 10 times 1 is 10, divided by 5 is 2. And now we have 20. 20 times 1 is 20, divided by 5 is 4. So the same process. Yes, we had to do some fraction work. That's all right. But we can't take those and turn it into an answer yet. There's one thing that we got to remember to do before we write out our final answer. Since there was a coefficient of 5 in our divisor, all of the numbers in our quotient, that's everything on the bottom row except for the remainder, has to get divided by 5. The remainder stays the same. So I was thinking the remainder is going to be locked up in that little box that's safe from the division. Everything else gets divided. Final answer here, what do we got? Constant x squared, x to the third, x to the fourth. So 2x to the fourth. 3x second plus 4x minus 2 with the remainder of 4 5x minus 1. And that's it. Okay, so that's the advanced level problems. Any questions? I feel like you guys are going to breeze through this homework assignment tonight. Just make sure you're checking your answers. Any questions? Any questions before we move on and talk about something else?